Okay, hi, my name is Alex Ivensky, and I'm here to show off some system functionality of the Ivensky Railroad LLC train control system. So we'll just fire it up here. And right now the Arduino is not connected for the hardware track controller, so the first thing that the user will see when they open the system is a warning that states the Arduino is not detected, and this will indicate that the user should not try to use the hardware wayside system. Now once you dismiss that, the launcher comes up. At the top you'll see our name, and over here you'll see buttons for each module. Now we have implemented a module hierarchy, which means that none of the modules can be opened until the track model is opened and a track model is loaded in here. So I'll go ahead and do that. Now that I've done that, now that the user can pick a wayside. So for this demonstration, we'll go ahead and pick a wayside, and we'll set that up as well. And to do that, my partner Keshov will demonstrate that.
Yeah, so once you open up the software wayside, you can either turn it to select a mode. So we have manual, where you can control the devices manually, and then automatic, where the PLC will automatically function. So for the sake of this demonstration, we can put it in automatic mode, and we can also select the green line to start. And from there, we can change this later, but we'll just choose a wayside for now and leave it there. Additionally, with this, we can also view the track map for this. So if we click View Track Map here, we get a map for the wayside operator to see where all the devices are located, which are shown by this key here. Other than that, the wayside operator can also upload a PLC program. So once they choose a wayside to that specific wayside, they can click Upload PLC Program, upload a text file that has the PLC program structure in it, and then click Submit. However, for the sake of this demonstration, the PLC programs are preloaded into the demo.
Okay, so now that the wayside has been set up, we can go ahead and dispatch a train through the CTC. So I'll go ahead and open up the CTC interface. This provides quite a few options for the user. So we can manually assign some stops to a train and then dispatch it. We can pick a line up here for which line we want to dispatch the train to. Up here we can see the time, and we can also upload a schedule, open a schedule builder, check line status for a certain block, you can check the track fault and maintenance status, block occupancy, toggle maintenance for a certain block, toggle a switch, and we can see occupied blocks, faulty blocks, and maintenance blocks on the selected line. Down here we can also see hourly ticket sales aggregated for the line that we have picked as well. So now we can go ahead and add a stop to a train that we want to dispatch. For now, I'll just do one stop for one train. I'll pick Dormont. Now you can see also we have numbers on some of the stations, and that refers to how many sides the station has on each side of the train. So I'll go ahead and pick Dormont, and I'll assign it to arrive at 12:10. And as you can see up here, it is 12:02. And I'll go ahead and dispatch that. Now the system has determined that the train should leave at 12:07 in order to arrive at the specified arrival time, so the train has been added to a queue. Once the departure time actually starts, the train will be moved from the queue to dispatch trains, and I can demonstrate that by just speeding up the time here in the launcher. Slow it down a little bit here. Okay, so now the train has been dispatched. It has a certain suggested speed, authority, current block, all of which are displayed here. So now that we've loaded the track map, the current block is actually displayed in the CTC. So if we go ahead and look at the track model interface, we can see that the train starts on block 63, comes out of the yard, and is now on block 64 as it makes its way down to Dormont, which is right here. As you can also see on the right side of the screen, the track model interface provides some key information about a block that the user can select. So if we select block 73, we can see first of all that it is a station because it does correspond to the Dormont station that we have commanded the train to go to. You can also see block information such as length, grade, speed limit, traffic light if there is one. So if we select block 76, we can see the current traffic light status. You can also see train ID if there is one there. So there's a train on block 67, train ID 0, heading southbound, has 6 blocks of authority, and a suggested speed of 25. And we can also see station information if we have selected a station. We can also choose failure modes if we want to for a selected block, and we can choose a track heater temperature also if we want to. Now I'll go ahead and show the train controller and the train model. So the train model provides a pretty basic interface. We can select any train from the system that is active, and it'll show all of the relevant information. So crew count, passenger count, we can pick a failure mode to simulate all these different failure modes. We can see train lights, doors, temperature. There's a button for the emergency brake for the passenger, there's service brake status, and then we can see all of its numerical values, such as length, width, height, mass, power, acceleration, and velocity. And down here we can see the current beacon, and we can see some advertisements as well. We can also go into the train controller, and we can select a train here as well, similar to the train model, and we can see a lot of the same values. Trains by default for the train controller are in automatic mode, but we can also switch to manual mode if we want to change any of these values. So over here we can see power, current authority, current commanded speed, current speed, and then we see a display for failures, which correspond to these over here. Now, as you can see, the train is approaching Dormont Station, so that gets displayed right here. And you can see the train has been commanded to slow down. Now it'll be dwelling, and the dwell time we specified, I think, was about 1 minute. So we can just breeze through that. And now the train is done dwelling, and since the train has no stops left that we have assigned, the train will just continue on through, and it will head to back to the yard. As you can see down here as well, as the train continues through a block that has a traffic light, the wayside will determine, based on the authority and based on other trains on the map, whether or not traffic lights should be on. So right now this train has no trains in front of it, so the wayside has determined that the traffic light on block 76 should be green. We can also see active switch direction for a block, which is also determined by the wayside. So currently the switch is going from 77 to 76 as is indicated right here. So we can see the train proceeding through this traffic light. And we can see that this traffic light is now red. Block 77 has allowed this train through, and the train will continue on.
So from here, one more functionality of the wayside is the crossing device. So if we see up here, 19, block 19 on the green line is actually a crossing, and we can see if it's active or not right here. So we can actually speed up the simulation and wait until it gets to block 19, and you will actually see the light and the gates next to the crossing come down. And that is defined based on if a train is basically a few blocks out from the crossing, then the crossing gates will come down and the lights will go on. So just to view another case here, we can go to block 28, and if we actually go to the wayside here, we can go to wayside 1, block 28, and we can also monitor the switch direction here. So as you can see, the crossing does come on here, and once the train comes back, you'll see it go on again, and the switch direction also changes again, 28, 29, and the train will continue onto the yard. A thing to add is the wayside is triply redundant, and we do that by technically having 2 waysides, but there is a third wayside that is connected to all the blocks. So every single iteration of this program, the waysides will all compare against each other. So for example, wayside 1, wayside 2, and then the wayside third one that controls everything will actually all check the same block's occupancy. And for example, if 2 of those waysides show that the block is occupied, but one of the blocks shows that it's unoccupied, it will implement a 2/3 rule and take the result that's the majority there.
Now, just to finish this off, I'll show a similar demonstration on the red line. So I'll do the same thing. I'll head into the CTC office, which I already have open. Choose the red line, and I'll go ahead and do the same exact thing. So I'll just pick any stop. I'll pick Penn Station, and I'll tell it to arrive, say, at 12:30. And I'll go ahead and dispatch it. Now, because I said 12:30, which is of course before the current time, the train just gets dispatched immediately. So if we go into the train controller, or say the train model, now a new train has been added, and we can see it is moving along. Oh, there it is. Yes, there is the train.
And as you can see, for this one, now there are 3 lights per per junction, since now these tracks are bidirectional for every single way. So as you can see, those still work perfectly fine, and the switch texturings do change if you click on one of the junctions.
And now I'm going to demonstrate the hardware wayside. So you can see that the hardware wayside is correctly plugged in. Okay, we run from the main backend. You do not receive an error message. If you want to show the screen here, there is no error message received as it detected that the hardware wayside was plugged in. Therefore, there is no need for a warning sign. So let's start the demonstration with the track model. We'll load in the track. We're going to do the green line. We'll put this to the side for now. Now we're going to load up the hardware wayside. And as you can see, the software wayside is grayed out, as that can no longer be selected. And we're going to go into the green line. You can view the map here and zoom in on it. And we're going to be looking at Dormont, which is 77, I believe. 76?
73.
73, sorry. All right, so let's go to the CTC office and let's dispatch this train. Go to the green line, and we're going to add a stop, and let's select Dormont. Okay, and we're going to dispatch this train. Now, if you can redirect your attention to here, I am now going to select block 73, which represents the station, and as soon as I select it on the screen here, it will be uploaded onto the Arduino. And as you can see, it is currently unoccupied. There are no track faults. So now let's go back to the map here and let's follow this train. So right now it's on block 63, right? And we're going to speed it up so that we can show it in a timely manner here. So we're going to load in, let's say 10 times. Right, set it 10 times. Let's go back to this here, and we can see the train follow along. So here it goes, slowly but yet surely. All right, it's getting close to 73 here, so if you just want to redirect your attention to the Arduino, it is now occupied as on the station, and then once it leaves the station, it will go back to unoccupied. Additionally, I would like to show that we can set failure modes from the track model, or sorry, not the track model, but the CTC office that will be received under the Arduino. So let's toggle the maintenance switch from the CTC office. So that has been toggled on. Oops, 1 second, let me select the right block. We're going to set to block 73, which is Dormont, and we're going to set a maintenance flag. And now if you would mind showing the Arduino, we'll see that it has an active maintenance switch, showing that the Arduino receives the maintenance signals from the CTC office and displays it to the LCD's display. All right, that is all for this demonstration. Thank you.